Hello everyone, my name is John Alexis Guerra Gomez, and in this tutorial I'm going to explain how to create these network visualizations using D3 Canvas and the Ford simulation system in D3 version 4. So let's get started. So let's go here into my desktop. I'm going to create a new folder called simulation, and inside that let me start Sublime. I don't know why sometimes I do this and I have to call it twice. Anyhow, so let's create a new file inside that is going to be called index.html. I'm going to use just a regular HTML template with a title in here that says Force Tutorial. I'm just going to add an H1 in here that says the same thing. And then I'm going to create a canvas element that I'm going to call network, and then it's going to have a width of, let's say, 500 pixels versus a height of 500 pixels. Since we are going to be using D3, then I need to include the library, so I'm going to use that from the CDN that Mike gracefully offers in the D3 website. And then let's start writing down our script. So to start working with this, basically we will need some data. So let me create that. So I'm going to save that inside a variable called graph. And that variable, it's going to be just, it will contain two attributes. One is going to be the nodes. That is basically an array of objects, and the other one is going to be the links, but we are going to do that in a minute. So let's start with the nodes. Each node in here will contain two attributes, very simple. And then an age that we can use for creating the visualization. Let's say like 36 or something. So let me replicate this. And oops. And then a bunch of nodes. So basically I'm going to say here is John, here is Mafe. And then I also have Edwin, there's going to be 39, and then I'm going to have Santi, that's 8, and David, that's 3, and finally Juliana, that is 30 years old. Okay, now that we have data, basically we are going to be drawing this inside the canvas. So I'm going to create some variables in here. I'm going to create a selection that is basically just selecting this network that we created up here, the canvas. And then apart from that, when you work with canvas, basically you need to be able to generate a context. And the way of doing that in here will be from the canvas. We are going to use the node call that basically returns the HTML element or the DOM element. And from there, I'm just going to say get context, and we are going to be using a 2D context. You can find more information about that online. All right, so apart from that, we are also going to be using the width and the height, and we're going to get that from the canvas just by calling the attribute width such that it changes. And I think I of course have a typo here. And then let's change this for the height, and the same one in here. So basically these two variables will get 500 and 500 each one. Okay, so the next thing I'm going to do is basically start drawing that on the screen. So for that, I'm going to create a function that I'm going to call that it's called update. And then this function is going to do something very simple. Since we are using canvas, so the first thing I need to do is just to take that context that I called CTX, and then I'm going to do a clear rect, which means I'm going to clear the whole canvas from the coordinate 0, 0 to height, width, height. Okay, and the next thing is that I'm going to do for each one of my nodes, I'm going to call the method draw node. So that's a method that doesn't exist yet, so let's create it. And basically each one of these draw node is going to receive the datum, so it's going to receive each one of these elements. And then what I'm going to do in there is to move the cursor, like as we used to do in Logo many years ago, to the position of the node in the x and dy. And finally, to create a circle. And for doing that in Canvas, we use the arc primitive. And then the circle is going to be centered in x and y. It's going to have a radius of r that I'm going to create a variable in a second. And then the arc is going to go from angle 0 to 2 times mat pi. So basically with that, we're saying we want a full circle. Now I also need an radius. So let's say that this is a radius of 3. And finally, so we are drawing that. Now, this is not going to show nothing yet on Canvas because basically the idea is that we need to tell it that we are going to create a path in here and then that we actually want to draw those things. So basically the way this works is that first it knows in here it starts creating something. Then for each one of my nodes is going to perform these 2 actions without yet drawing anything. And then after all of that, it's going to draw all of them. So this is, I think, a little bit more efficient, and we'll see in a minute how that works. Let me just create a global in here, D3, such that my linter stops complaining. And I think, oh, and we have a problem. So if you guys see in here, I'm using dx and dy. However, none of my objects contain any x or y whatsoever. So those are variables that are going to be controlled automatically by the simulation system, but since we are not using that yet, so let me do a hack in here, and then for each one of my elements, I'm just going to assign a random dx point, saying mat, I think it's random, not sure, like this, I think, multiply by width, and then do the same thing with the y, but in this case it's going to be multiplied by height. Let's align this nicely. And then basically we're going to have nodes that appear on the screen on different positions. Let me start an HTTP server in here in position 8080, and if I run that, voila. So now we have nodes appearing in random positions. Okay, cool. So that's nice, but that's not really a network visualization. So let's go a little bit further. So I'm not going to use this anymore. And then what I'm going to do is to start creating the magic of the D3-4 simulation. So when I do that, basically I just need to call this function. And that will create a simulation object. And in each one of those objects, I can do many things. So the first thing I need to do is do something whenever there is a new tick on the simulation. So basically this method is going to be called many times every time the simulation has a new value. And basically that will create the idea of the animation. In this case, since we have this update function, we are going to be calling that, and it's going to be moving things around. And to see and then how this thing works, basically we want to create forces. So let's create a simple force that takes elements and takes them to the x position with under 2, which means in the middle of the screen. And then finally, the only thing I need to do is just to say, and I'm removing this because simulation is going to take care of coordinates now, or actually let's put it in here. It's going to say the simulation, the nodes of that is going to be my graph.nodes. Okay, so when I do that, now I'm using that, and then this is going to be called. Let's see how that looks. So if I run like that, you see that the nodes are actually going to the middle of the screen. So now I can actually say, well, I also want that same behavior on the y position. In this case, it's going to be with the height, and it's going to be a force y. So if you do that, you see all the nodes are going to the center. So now we have a simulation, and the tick is getting called several times, and each one of those is bringing the nodes in there. We can actually bring this a little bit bigger, but we'll do that in a second. So the next thing I want is to create another function that actually says, you know what, I don't want my nodes to collide. So this new force simulation system has a nice function that's called force collide, and then you just pass to it what is the radius of each one of the nodes. Then when you do that, it actually makes sure that the nodes don't collide. Then I can actually make this bigger just to see if it is actually working, and you see that there are one on top of each other, but they're not colliding. And if you actually want a border, then you can add like a little bit of threshold in there, and then so the nodes actually differentiate. Now, as of now, I have two forces. I have one force or three forces. One force sending the nodes to the X position, to the middle. Another force sending the Y position to half of the screen too. And then a force avoiding them to collide. The other force that is very useful is the charge force. So if you use the charge force, basically it creates a system in which each one of the nodes will try to repel the others. And then if you just do this, you see the nodes, they're not moving too much in here, but it's because of the strength that it has and the size. So I actually can add a little bit more of strength, and let's say, and this takes negative values if you want the nodes to stay away from each other. So when I do that, you see that the nodes try to separate. If I add higher values in here, higher negative values, then they will try to stay away of each other. If you put a positive value in there, they will actually get together. And then if you see these with smaller values, then you still can see them like moving around. Okay, good. So this is really nice. Now we have forces that avoid collisions, that allow nodes to separate themselves, but I need another force because this is supposed to be a network, so I actually need some links. So let's start creating some links. Basically, the links is another attribute that is going to contain objects. It's another array, sorry. It's going to contain objects that have a source. In this case, I'm going to say the source is John, and a target. I'm going to say that the target is Mafe. Then I'm going to create several of these. That's better. Beautiful. So now I can say that John is connected to Mafe, and John is connected to Edwin, and also Edwin is connected to Santi, and Edwin is connected to David. Oh, I made the same mistake again. Santi. And Santi to David, and finally Edwin to Julie. Let's do that. Let's just create something that doesn't make much sense now. So I now have my links. Now, if I actually want to draw them, then I also need a function that will draw my links. So I'm going to create a function in here that is called drawLink. I'm going to change this variable for an L. And then basically I'm going to do the same trick. I'm going to move the cursor first to L, but in this case the link itself doesn't have a coordinate, but it does have the source and the target. So I'm going to move into the source coordinates, and then I'm going to draw a line to the target coordinates. And those are the two coordinates of the link. So it goes from one node into the other node. And then I repeat the same trick. So I can actually put this in here and say instead of the nodes, I'm going to do that with the links. It's going to be draw link. And instead of a fail, it's going to be a stroke because the links, they don't have any filling. Okay? So with that, I will be drawing them. But even if I try to run it like this, and then if I do it here, you will see that it's still not drawing my links. And the reason for that is that you see I'm using l.source.x. But if you look at the links, I only have a source that contains a name. So the reason why that will work eventually is that the simulation system will take this John, and then will search in here, and then it will replace this whole element with this item. And since the nodes, it keeps on updating them with the X and Y coordinates, then it will work. Okay, so to do that, the next thing I need to do is to add a new force. In this case, it's going to be called a link force. And it's just a D3 force link, go figure. And basically the same way that I was assigning here the nodes, I need to assign my links. However, I don't assign the links saying dot links because the links are just yet another force. So I need to get that force first. And then that force is the one that contains the attribute links, and for that I will assign my graph.links. Okay, let's run like that this, and let's see what we get. So now it is complaining a lot here in the console. You can see that it's not finding the Maffei, and the reason for that is that originally D3, like the basic of if you don't pass any parameters, is that the source should be an index of the nodes array. So in this instead of John should be like 0, knowing that this is the first element. But since I like writing things like this, I'm just going to tell the link how to find the nodes. So I'm going to say the ID for this is going to be a function that for each node you just have to look into d.name, and that's it. Okay, so if I run that again, let's see. Yes, so now it is working, and then we actually have our network. Good, perfect. So the next thing that we can do is actually load this with real data. So this is just a toy example, so I'm going to remove this. I'm going to use that anymore, and I'm actually going to be using a file that I have been playing with, that is this Votaciones Senado. It's a file that contains all of the voting patterns of the Colombian Congress. Basically, it has each one of the congressmen and congresswomen, and then it also contains their party, that in Colombia it's like 20 or different parties. And then if we look into the links in here, it will contain how many times these two senators have voted together. That means that have had the same opinion on the different laws that they have been debated. This contains data for the last 3 years in Colombia, and it's quite interesting. So let's load that. And the way of doing that is that I'm going to call D3JSON in here. I'm going to be very lazy and just copy the name just to avoid mistakes. And then remember that the function D3JSON will receive another callback that basically contains an error variable that if gets assigned, basically it's something went up. So I'm just going to throw an error. And then I will contain here my graph. Now, that's what I'm going to use to assign my elements to my simulation. And then as you see, my update also depends on the graph, so I'm going to put that inside that too and make use of the closure of JavaScript. And then finally, I was calling this update manually, so I won't do that anymore. Now I have to call that update. So that was called here on the tick on the simulation here. So now I'm going to do that after loading the data because I don't want that to happen before having any data. So I'm just going to say simulation on tick. So another way of doing this, that it's a little bit more D3E, will be something like this. So we can say, here are my nodes, and then finally link. Okay. I have to do it in this order because if we try to do first the link and then the on tick, I think it will not work because it's returning the force. This in here is returning the force of the links and not the simulation per se. So with that, let's load it and see what we get. And as you can see, now we have this ugly blob, and it's because we are drawing the links on black. So let's change that. And the way we can do that is just to say, first, I'm going to say that they are not that opaque. So I'm going to put some transparency on it. So I'm going to say the global alpha in here is going to be 0.1, whereas for the nodes is full opacity. And then the other thing is that I'm going to say that the struct style is going to be a color of AAA. Okay, so that's like a gray, I think. So by doing that, we do get like a better chart in here. And now the final touch I want to give to this, it's to give some colors. So I'm going to create another scale in here. There is a D3 scale ordinal. And that one is going to receive the scheme of the category 20. And comma, so we get to the next one. And then the next thing I want to do is that before drawing each one of my nodes, then I'm going to say change the fill style to be the color of the d.body. That is the attribute that contains the body. And I'm going to do something ugly, that is just to do the begin path and the fill inside the draw node, which is a little bit less efficient because it's going to create many more paths, but is what I need to be able to actually draw the actual colors. And then you go. So this is quite interesting, but I still want to know who are these interesting nodes. So what I'm going to do is that if you guys search for the D3 Force documentation, then you go to the GitHub page. You will see that Mike has here several examples, and I'm going to use this one in here that contains some dragging behavior that I'm going to copy. So basically the idea in there is that I'm going to be using these three functions. So I'm too lazy to write them myself. So let's put them in here. Basically, if you look at them, what they're doing, they're just taking this D3 event subject, which is going to be a node out of my graph.nodes. And for this to work, I actually need to also add this other function that is the one that is going to search for that. If you guys see, that one was included inside the D3 JSON call. And the reason for that is that this uses something called simulation.find. That it's a nice method that Mike Vostok provided to allow us to search inside the canvas for a specific coordinate and to return the node that corresponds to that. So now we have the four methods. Then I'm just going to copy this too. And so basically, if you see in this example, the canvas Mike was using was obtained in a different way. He was using just the regular document query selector. So in our case, canvas is a D3 selector. So actually, I don't need this. I just can do like the regular canvas because that's a nice selection. But I will need to change this container in here because that's supposed to be an HTML element. So I get that by just calling node, and that should be it. Let's see if we can get this to work. So if I get a node now, you can actually see I can actually drag it. And then to show that that wet node is that one, you can actually print here the D3 event subject. That is the one that was found in here during the drag subject, okay? And that will print my whole node. So every time I start dragging a node, you will be able to see what is the actual senator that was working in there. Now, the nice thing about the simulation system is that you don't need to send things into specific positions. So, for instance, one of the things I can do is that instead of sending this to force X to the middle of the screen, I can send it a little bit to the left. And then you will see that the whole chart moves in there. Or you can actually move them, each one of the elements, into a specific position. So for instance, I can say I want to move each one of the senators to an X position depending on the party that they are in. So I'm going to do that, creating a new D3 scale ordinal. And then it's going to have a range that goes from, let's say, 20 to width minus 20, just such that it doesn't go into the borders. And then basically, depending on each party, it's going to assign a position. And if you do it that way, that you see that it's actually distributing the nodes. It's trying to distribute the nodes, but because of the links, it's a little bit too difficult. So we can actually make this force to be a little bit stronger. So I can add a strength of 0.6 or 7, for instance. And when you do that, you see that it's actually pushing really hard to get things in there and stretching them with the links. You can also play with things like, say, oh, the link, strength linked, I don't want it to be that hard. So you do that, then actually nodes start getting into different positions. So that's why this force simulation is quite interesting, because you can add your own forces and create very interesting charts that depend and change depending on the attributes of the data. So that's what I have for today. You will find a GitHub repository that contains each one of the steps of what I have been doing in here, so you can follow at your own pace. And if you have any questions, please do let me know on the comments of this tutorial. And thank you very much.